morning, everybody. How are you? Today we'll talk about trigonometric functions. We will talk about both functions, sine and cosine. But before we start talking about that, let me give you the real solid introduction. Let's think of a circle, okay, with a radius of 1. And any point in the circle has coordinates x and y. So if this is 1, how long is this one? Also 1, but its coordinates 1, 0. This is 1, so its coordinates, so when you are at 90 degrees or pi over 2, the coordinates at that point is 0 and 1. How about here? It's the same but opposite. Why? Because at 180 degrees or pi radians, the coordinates are minus 1, 0. When you go full circle, what is the angle? Either 0 or 360. In English, we can call it 2 pi radian. 1 pi plus 2 pi, 3 pi over 2. So this one here is 3 pi over 2 radians or 270 degrees, where its coordinates are opposite to that one, 0, negative 1. Now, let's try to, the whole circle divided into 4 quadrants, 4 quarters. This is called the first quadrant. Therefore, this is your second. That's your third. And that's your fourth. All right? Now, what's important over here, that if this is called x and y, this length is called y, and that length is called x. Oops, we have right angle triangle over here. If I call this angle, when you go, it's called theta. This theta is positive. Why? Because whenever you go opposite to the arms of the clock, we call it in English counterclockwise or anti-clockwise, angles are always positive. While if we go that way with the arms of the clock, this is called clockwise, and the angles are always positive. Sorry, negative. So there's something to keep this basic information before you do anything else. Now, is there a relationship between x and y and r? First of all, let's ask a question. What is the sign of that angle? I'm going to write and I'm going to clean so you can take notes later on. If you look at the angle sine theta, what is the ratio of sine theta? It's the opposite over the hypotenuse, and the hypotenuse is called 1, and y over 1 is y. Remember, whenever you speak sine theta, it's y. How about cosine of an angle? The cosine of an angle is the adjacent over r, which is the radius, and x over 1 is an x. So the ordered pair x and y is equivalent to the ordered pair in terms of theta is sine theta and cosine theta, and that has to be solid number. There is something else beautiful. The relationship in that, by using Pythagoras rule in this triangle, you can tell that x squared plus y squared equals 1. And since x is cosine, so cosine squared plus where the y is sine, sine squared theta. You can write the square inside or you can leave it outside, it doesn't matter. So that's an identity. Remember this one, it's called the first identity in trigonometry. We can always use it and go back for it. There's another relationship. What is tangent theta? Tangent theta is the opposite over the adjacent, y over x. And what's y? Oh, y sine. And what is x? Is a cosine. So there is another identity. These are both identities. Remember them. We don't have to prove it more than that. I can use that later on when we teach solving equations. So gentlemen, remember from now on, x and y are what? Cosine theta, sine theta. This is the ordered pair. You cannot have it backwards. So some people ask you, what do I get for that? If I ask you, what's sine 0? Sine 0, it's 1, 0. How about what's cosine the angle 0? Or cosine 360? Or cosine 2 pi radians? Cosine is the first, this one, 1. What is the sine of 180? This one, because that's sine, 0. What is cosine 90? This is cosine, the answer 0. What is sine 90 or sine pi over 2 radian? This is the sine. This is the key. So sine 1, sine pi over 2 is 1. And so on. So we can find these answers without going to calculator. Just knowing these basic things. All right? Now, the second item. Let's think about the signs of sine theta over here. You know this quadrant? All angles in this quadrant are between 0 and 90. 0 and 90. That's why we call them acute angles. Angles are acute. But if you are in the second quadrant, where angles are between 90 and 180, you can write it in terms of radian. Then in this situation, the angle is like that one. An angle like this opens this one and it goes all the way. This kind of angle is called an obtuse angle. While if you're in the third quadrant, where angles are between 180 and 270. If these angles are in between, then an angle like this. You have an angle who starts from here and keeps going all the way somewhere in the third quadrant. This angle has a name and we call it, guess what? Reflex angle. While an angle, if it's more than 190, 180, 270, if an angle is more than 270 or 3 pi over 2 and less than 360, then the angle is also called a reflex angle. Keep these basics with you all the time. What do I get from doing that? So if I want to know the sine of any angle or the cosine of any angle in that quadrant, any angle, the sine is x, sine is the y, and the y goes up that way, so it's positive, so the sine here is positive. While the cosine, that one, x goes along the x-axis, so also it's positive. When you divide sine over cosine, the answer is tangent, so plus divided by plus is plus. Likewise, when you go to second quadrant, what are the sines of any angle whose sine or cosine or tangent are between 90, like sine 120, sine 130, sine 140, cosine, what are their signs? You know that the x is the cosine and goes that way. That's negative. The sine, it's up, it's y, going up. This is y. This is the y-axis. So this is positive. And when you divide them, it's negative. That's the sign for the tangent. Likewise, in the third quadrant, what is the sine and the cosine and the tangent? Sine. So if an angle is 200, 220, 230, 190, any of these angles, their signs are, since the angle sine theta is going down, so down means y, and the y-axis this way, it's negative, and the cosine going that way. Negative divided by negative is positive. The same game we can play over here. What are the signs of sine, the cosine, and the tangent in the fourth quadrant? The sine, it's y. And y of any angle, even if it goes that way, you can tell it's going down, so it's negative. The cosine is positive because this is the way it goes. And then negative y by negative is negative. So guys, these are keys are so helpful in this chapter. What else here we have? There is one more thing that sometimes we don't pay attention for it. Let me clean that one. You need them, but you have them already, so there is no need to fill the bowl with everything. You know when you go to the beach, you have a beach chair. You sit on this one. And this is your neck, this is your back, and this is the beach chair. Okay? This angle that backs you up in here, it can be called supported angle. It supports your inclination. So this has many names. Sometimes if this angle goes that way, you are more relaxed, you can sleep. But if you want to eat, you want to keep it that way. You're going to keep the angle that way. So this angle, it has many names in mathematics. We need to know it. I will call it reflex angle. We can call it fundamental angle. All right. Let's give it a name, RA. There are many other names for it. So I'm going to call it this backup angle, which back you up, it's called RA. R has a name. I'm not going to tell it now. I'm going to wait for you to do some research. Now, what do I benefit from that? What's for me? How can I use it? Okay, I cannot wait. I'm going to call it reference angle. I was hoping that you go away and find out, but there are many names for that angle. Each quadrant has its own reference angle. Let's, for example, look at this. If I have an angle who's 120 degrees, this is called obtuse. What is its reference angle, RA? This is the one. It is 60. How did I know it? Yes, it's easy. Because all of it 180, take away 120, it is 60. Is there a definition for that? I'm not going to tell you that. Suppose I have an angle of 210. What is its reference angle? The reference angle is very back to the x-axis. And what's 180 minus that one? Is about 30 degrees. So some people say, how do you know how to find the reference angle or the fundamental angle? Let's not put it anymore as fundamental. Let me give a simple definition. The reference angle is a positive angle. And what do you notice? It can never be more than 90. It's an acute angle. What else? The reference angle is connected to the x-axis, and that's the secret. Only. So, why do you think I chose the 30? I didn't choose this one. For even though they are both acute, both positive, but this one is connected to the y-axis. You don't want that one. So, the real definition of reference angle is the angle drawn between the finishing side and the x-axis. So I can simply say, what does that mean? So this is the reference angle. Some people said, why do you say that? Because when I drew the angle from here, it's all the way until there. This is the finishing side. This is the starting side. Where is my reference angle? It's between the final side, the finishing side, and this one. So it's common sense if you know what to do. Let's, for example, talk about that one. I'm giving you an angle who is 300 degrees going anti-clockwise. This is your theta. Can you tell me what's your reference angle? Easy. Positive, acute, and it's between the x-axis and the finishing side. This is the one. So what is 360 minus 300? 60. So there is no need to start. If you mess up this one, you mess up everything. Now the smart question. I may have an angle who is 80 degrees. All right? This is your x, this is your y, this is my theta. I want its reference angle. How can I find its RA? What's the definition? Positive, okay, never put negative. Acute, it has to be, but this is 80 and this is 10. Which one I should use? Should I use the 10 or should I use the 80? Well, the definition said, if an angle starts from here, starting side, keep going all the way until you stop, this is called the finishing side. This finishing side, the angle between the finish and the, remember, the x-axis. So you are so lucky. In the first quadrant, the angle is acute and its reference angle is also what? 80 degrees. Little examples, they are helpful, but I'm not going to tell you why now. Let me give another example. You have an angle whose, let's say, 100. Your theta is 100. So what is your reference angle? Your reference angle for common, some people will say this one. No, it's between the finishing side and the x-axis. If, 100, this is 80. All right, guys, keep these little stupid things in mind. So that's a very important notation or important definition for solving trigonometric equations. This topic has 3 lectures. This is the first lecture. All right. Now, once you have all of that done, then I can proceed with the same topic, with the same sketch next time. What's next time about? I'm going to tell you how would a sine function look like, how would a cosine function look like, and what do you mean by amplitude or period or blah, blah, blah. That will be our second lecture. By the way, this circle is a famous circle. Everybody knows about it. It's called the unit circle. In Arabic, دائرة الوحدة. Have a nice day.